G'day YouTube, warbles on a lot here. Welcome to 2021 and let's start off with a video about atmospheric condensation water mining. And yes, you did hear that right, atmospheric condensation water mining. I'm sure if you're a YouTuber of any great standing, you will have encountered the debunking campaign which has been launched by a British-born physicist or nuclear physicist, name of Philip Mason. His channel is Thunder Foot. Voice of Thunder is another one of his channels. He makes extraordinarily long debunking videos and he has a lot of fun and his science is really good. And one of the things he's debunked is the idea of a water seeker or water seer or something like that. And from memory, it had a helical wind turbine, not much bigger than that one. And the turbine was supposed to drive a fan. And the fan was supposed to suck atmospheric air at ground level, or maybe a metre off the ground, down into an underground chamber, a metre, 2 metres underground, where there was supposed to be condensation occurring because of the chamber's cold walls affecting the atmospheric air, precipitating any moisture out of the air and collecting it in the underground chamber. And I think there might have been a solar panel and a battery and a water pump to bring the water back up to ground level. Somebody had this brain fart. Somebody developed a computerized presentation. I don't know enough digital technology to know how it was done, but it was pretty much all cartoons and CGI. And they launched a GoFundMe campaign and they sucked in hundreds of thousands, if not millions of dollars from people who thought it was a great idea. And the underlying theory that you should be able to cool down ordinary air and precipitate out the water as it condenses from vapor into droplets, the underlying idea is not wrong, but the amount of air involved and the amount of energy involved means that it's generally a pretty stupid project to get yourself involved with. So why am I getting into the arena, so to speak? It's like this. Once upon a time, Louis Pasteur said that chance favours only the prepared mind. So perhaps watching Thunderfoot's videos has prepared me to think about these issues. But the fact is that last year, when I spent a lot of money on being able to put water out through sprinkler systems because I was afraid of being burnt in the bushfires and I wanted to have a wet spot on which to wait the fiery end, I cobbled up some infrastructure that's fairly unusual because it suits my purpose and not many other people share my purpose, you know. There's not a lot of people who decide what they want to do is run an irrigation sprinkler. This is a 20mm specimen, about 3 metres off the ground, screwed onto the end of a piece of 32mm agricultural polypipe atop the tower of what I call shower and light because it's festooned with lights and it provides a pretty good shower. Now, I'm not saying that nobody else has irrigation sprinklers mounted up on the top of towers, but most of them, I'm assuming they would have their system permanently connected to a water plumbing network all of the time. This thing, it's mounted on the end of a length of polypipe, and the 32mm polypipe descends vertically to a 25mm Storz connector, which is fed habitually by the 25mm Storts connector on the 6.5 horsepower fire pump, and I have a couple of little 12-metre hoses to connect the two. And what it means is that every time I use this setup, after I finish, I disconnect the hose and all the water falls vertically down out of the pipe. And then, to prevent wasps plugging the lumen with mud, I use one of the $29.50 25mm Storts end caps. So that's watertight. The other end of the 2.9 metre long tube has two little openings in it. One at either end of the spray head. Quite small openings, two of them. Neither of which is angled in such a fashion which would facilitate or enable it to catch rain. I think that's a fair statement. And so the first time in the middle of a drought that I dismantled the system after a night's irrigation sprinkling using dam water, and the water drained out of the vertical pipe, and I put the Storts cap on, and then 2 days later I went to sprinkle irrigate again, and I got the whole system set up, unrolled the hose, went to connect my nylon hose to the bottom end of the 32mm 2.9 metre long polypipe going up to the 25mm irrigation head. I took the Storts connector off and some water came out, like half a teacup full, I don't know, I didn't measure it. It fell out, and it surprised me because, like, there hadn't been any rain. And it took a couple of repetitions before the penny dropped, and I realised that what goes on is that during the day the sun shines on that black plastic polypipe and it heats it up. Now there's a piece of black plastic polypipe sitting in dappled shade, and it's 35 degrees. And so presumably is the black plastic polypipe up at the top there. So the air in there's at 35 degrees. And during the day, as the sun shines on the black plastic polypipe, pretty much all of it gets sun heated. Mind you, at the moment, the actual temperature is only 21 degrees. Under the trees, so it's at 11 o'clock daylight saving time, which is actually maybe 10 to 10 regular local mean time. Let's just say that in full sunlight on a hot day in summer, you might get 30 degrees air temperature and 60 degrees polypipe temperature, therefore 60 degrees temperature for the air inside of it. That's during the day. But then during the night, not only does the air get colder, not only do you get no solar radiation going onto the polypipe to heat the polypipe, there's also a phenomenon called black body radiation. So if you get a metre or so up off the ground, ideally 2 metres would be a better height, and pretty much most of that pipe over there is more than 2 metres off the ground. Your black body is going to attempt to radiate its heat out into space. Now, I don't know whether you've ever got an infrared thermometer and pointed it straight up. You'll find that the sky is pretty bloody cold. Maybe colder than the thermometer's ability to register. And at night, it's really, really cold. So at night, the plastic material which is in contact with the atmosphere, it's absorbing heat from the air but it's radiating it out to space via black body radiation. It's a little bit complicated. It doesn't quite break any laws of physics, but it means that metals and glasses and dense plastics, particularly if they're painted black, they can get significantly colder than their immediate surroundings. It's why if you crash your aeroplane in Antarctica, you don't sit in the aeroplane and wait to be rescued, because it's metal and it's a heat sink. What you do is get out and build yourself a snow cave, because snow won't get any colder than it already is, and it'll actually act as insulation from the colder outside wind, and it's the constant flow of the wind which sucks the heat out of your body. So black body radiation, it's a thing. And what's been going on is during the day, that bit of pipe with its two little holes up the top, which are either too small for wasps to be interested in, or the constant airflow in and out stops the wasps from being interested in it. I mean, would you want to try and build a mud nest in a tiny little hole that every day expels air at 50 or 60 degrees Celsius? For whatever the actual reason is, those holes don't get blocked. I've had this system up the pole for a year, and it worked perfectly a month ago when I put out 5.5 tonnes at night on the 1st of December, because this hole clearing was dry and the trees were starting to look thirsty, and I didn't know if the forecast La Nina was going to come off as promised. So I started back into my watering routine. And what that means is that Stort's end cap that I just showed you at the start of the video, it's been on there for a month, because today's the 1st of January. This means I can go over there today, and with the aid of a piece of technology called a bucket, I propose to empty it and see how much water has collected in the pipe over 1 calendar month. And because mathematics, we can say with a fair degree of certainty that there are 8 square centimetres of surface area in the lumen of this thing, and there are 1,000 square centimetres of surface area per linear metre, right? So what you wind up with is every metre has 800 mils of airspace, or 0.8 of a litre, and each cubic centimetre has 1.25 centimetres or square centimetres of wall contact surface area. So that's actually not a bad volumetric mass to surface area ratio. And with 2.9 metres, 2.926 metres, we get 2.3408 litres of internal volume. Okay, let's see how we go with this. As forecast. And even then, I spilled some. Now, let's go and see how much water that is. In theory, this is a 250 ml measuring cup, but it's been in use measuring chainsaw fuel and two-stroke oil for 25 years, and I'm pretty sure the plastic has shrunk. So I'll just use that as an intermediate holding container into which we pour 1 month worth of condensed water from almost 3 metres of 32 ml polypipe, which these old measurements allege to be in the order of 225 mils. And when we put that through an actual calibrated medicine measuring cup, a protracted process which I will spare you having to watch, you'll just have to trust that I'm doing it properly. 200 mils. 200 mils from 2.9 metres of pipe, which is 68.35 mils per metre, divided by 30, 2.278 mils per metre per day. So if we imagine 50 metres of pipe, you would get 113 mils per day. So it would take you 8 days, maybe 9 days, to condense a single litre using a solar thermal barometric passive condenser with 50 metres of 32mm polypipe. And when I bought this stuff, a 150 metre roll of it was about $180. So if we allow for inflation and such like and so forth, you might find that $200 worth of polypipe would enable you to make 3 atmospheric precipitation water condensers, each one with 50 metres of piping in it, say 10 pipes standing 5 metres high, and that would get you a litre of water every 2.5 days. If you had relative humidity being as high as it's been here for the past month. And just reading off, 52%, 50%, 62, 68, 62. 60%, 60%, 60%, 50%, 60%, 62%, 61%, 62%, 65%, 71%, 74%, 70%, 75%, 62%, 70%, 74%, 75%, 65%, 65%, 61%, 70%, 64%, 65%, 65%, 69%, and 70%. So on the one hand, at the end of the month, the accumulated water only occupied 6.8% of the entire length of the enclosed airspace. So I don't think that any rational argument can be made along the lines that, oh, if you emptied it every day, you'd get more water in the end because you'd have a completely empty airspace with which to start every day. 200 mils out of 2.96 litres, that's not a factor. And on the other hand, this thing has just had an absolutely perfect run of high humidity for a month on which to be tested. So this was actually kind of the optimal conditions. Maybe it could be a little bit better if there wasn't all this woodwork around the tube, if the tube was in full sunlight for its whole length, able to radiate out a bit more heat at night, pick up more heat during the day, but I don't think you would improve the overall efficiency of the setup by any more than 10%. Like, you wouldn't get a 100% improvement in efficiency by having a freestanding black polypipe geodesic conical helical tower. So, there. Yahoo yippee. That was a very successful experiment. It literally cost nothing because I already had literally all of the equipment. It satisfied a curiosity which has piqued my mind for at least a year, and it came up with an end result that saved me from being tempted to go out and buy a whole roll of polypipe and spend days cobbling it together and erecting it in order to find that it's not worth doing. Small scale experiment with materials all ready to hand. And I'm sure I could have Wikipedia'd or Googled the figure on roughly how much water a person might expect. But it was a bloody lot of fun to figure it out for myself from measurements. And anybody who wants to say that there is some way that you can, for free, using natural interflows of energy throughout the environment, extract more moisture from the air than you get when it rains, or when you get a heavy dewfall on a roof that's got plumbing connected up to it to a water tank, you can feel free to quote this example as an illustration of why it doesn't work. Nearly 3 metres of pipe vertically up in the sky, sealed, restricted inlet at the top of the pipe, 30 calendar days to get 200 mils of condensed water. And that's when you've had no days with a relative humidity less than 50%, quite a few where it was above 70%. Those humidity readings are taken in the morning. And they're taken inside the hut too. I haven't tried it outside where there's not a 10 or 11 stone human being metabolizing and breathing all night in an enclosed space where the detector is. You might want to take 20% off those readings, perhaps. Although I noticed that my relative humidity readings off the wall in there are generally not far off whatever the media broadcasts when I run into a weather forecast which mentions it. Ah, there we go, and now we know. It's not worth doing to try and build a water condenser to mine the atmosphere for free drinking water out of Polypipe. If it won't work on top of a mountain in a La Nina, it's not going to work in a bloody desert in a drought. Warbles on a lot to YouTube. I thought you'd like to know that. Happy New Year. Ciao.